The last class के अंदर we started this chapter. This is systems life cycle, and into this chapter I discussed with you कि अगर हमें कोई भी सॉफ्टवेयर या कोई भी सिस्टम बनाना होता है तो उसके जो है वो कुछ नंबर ऑफ स्टेप्स होते हैं। उन नंबर ऑफ स्टेप्स के अंदर आपके पास जो सबसे पहला स्टेप होता है वो ये होता है कि आप एनालिसिस करते हैं। एनालिसिस के अंदर जिसके अंदर आई फाइंड आउट that how my current system is working and what are the current requirements and specifications, because if you do not know it, you cannot come to a solution. There are certainly different ways of doing your analysis. The first one can be questionnaires. We discussed into our last class regarding the pros and cons of questionnaires, that what advantages it give to us and what it does not. Similarly, I discussed with you regarding the interviews, that both of them are accurately some source of knowledge for us, but both have different points. Like, for example, when it comes to questionnaires, I'm giving it to the group of people. They can simultaneously give solve that a different number of questions, which is an indirect source. But an interview is to be known as a more direct one, because you are referring to a single person or a single entity. You are asking the question one to one or face to face. There can be some problems in the answers as well. Like, for example, in your questionnaire, some people might not give you the accurate answers because they would know that they are under a survey. However, there can be some problems into an interview as well, as when someone knows that they are being observed, they might tend not to reply accurately, or they might not tend to show the way that they actually work. We have observations as well, that goes for the same for it, and documentation analysis as well. That means that looking forward your current document, so that you would know that what is your current what is your current specifications. And the contents of specifications, it is divided into three areas. We have requirements, we have design, we have system. Into requirements, this is mostly created by your analyst, so that this is basically a contract between your developer and your client, so that you must tell your system that what it must do. Your design specification is created by your designer, that is mostly based on the look and feel, that how your software is working. And your system specification is created by the designer, that identifies the required hardware that is needed to run the system. And then we have our design area. Design area is quite important as well, because it is the roadmap through which you design your journey, or you design your algorithm of code. The first one is your data flow diagrams, DFD. I discussed this. I gave you the examples as well. We discussed the flowcharts as well, data storage as well, input forms, validation routines, output reports, and we need to start from testing, right? Uh, when it comes to your development and testing, now you are done with the two basic stages. The first stage was 16.1, which was analysis. The second stage was your design, and now it is the time for you to develop your algorithm. Your development stage is often referred to as the implementation stage as well, because at this stage you are implementing your program. Development is basically the stage in your system's lifecycle when you are producing that software. And right after you have produced that piece of software, then it is time to test it with the required data set to check that if it is even working correctly or not. To test that data, I have different examples. Like, when a system has to be developed, it needs to, when a system is developed, it needs to be tested, so that you would know that if it is properly or accurately working or not. A test data will be used. A test data is used for testing a system. There are some examples of that. Like, the first example could be a valid data. For example, I said that you have an exam of 75 marks, and you said, sir, I secured 60 out of 75. This is an example of a valid data because it is an acceptable value. But similarly, you said that, sir, if I secured 100 marks out of 75, that is an invalid data. That is a data that will not be accepted by your validation routine because it is out of your range. Similarly, you have also the example of an extreme data. For example, you have your test marks which are ranging from 0 till 75. So the minimum mark that you have is 0 and the maximum mark you have is 75. I did discuss with you regarding this that I have two genders examples as well, like male and female. If anyone add any other than that, it is not going to be accepted. Then similarly, following some examples of testing, that is an alpha test and that is an beta testing. Now, I have discussed this as well, I remember. Alpha testing is carried out by your developers or specialized teams of testers before a system is delivered to the user. That means that you have created that software, but before even sending that to your client, you are testing that. That means that this is an in-house testing. This usually takes place at the end of the development stage, and alpha testing, it can take a long time because just in case when an error is found, it has to be tested again and again. The second one is your beta testing, and the difference between both of them is that into beta testing, your software is made available to a large number of customers. That means that now they have the accessibility to use that. Alpha testing is basically planned and structured. So it creates pathways as bugs are found and they are notified by your customers, they are fixed. Alpha testing is an initial testing of the software that is by a limited group of people, that is mostly in-house, like group of people, in-house developers. And beta testing can be a pre-release software that is made available to your customers so that you can test them. ISM have two types of tests other than this as well. That is a black box testing and white box testing. And black box testing involves selecting your input data and checking that if you have that exact value or expected outcome or not, with no knowledge of what is happening inside your algorithm or what is happening inside of your program. For example, you created a program and right, you are a layman. You do not know that what is actually happening into that program. However, you provided some of the values and estimated that this should be your expected value. So it's up to you that if your software is accurate and if it is working, it would return that expected value. However, if it is not, then that means it would not get you the desired results. But when it comes to black box testing, the main area is that you have no knowledge or you have no understanding of what is happening inside the black box. The terminology here, black box, is to be understandable as a part of your algorithm. The second area is your white box testing, and in white box testing, it is involving the process of your input and output data regarding the internal structure and the logic of the programs that are known to your testers as well. I can say that a white box usually takes place with the small modules and is carried out by software developers who code the program. They do that so that they ensure that each module is working accurately so that they can even test the pathways as well. When it comes to black box, this is the testing on the user's end. It can be carried out by specialist testers as well in case of some specific testing or users. However, you do not need any sort of programming language understanding of programming language to test it. White box needs access to a detailed specification, whereas black box does not require knowledge of how the system has to be developed. That is quite one of the difference into your testing as well. Like a black box testing, you have a limited number of testing scenarios and you do not have no knowledge that how it is working. Whereas with black box, each module is to be tested separately. You have break it down your program into different modules and now you are testing it separately. So this is white box. You can also remember it quite well with the example of aeroplane, right? Like for example, every aeroplane have a black box in it, and unfortunately if it crashes, what happens is that the team searches for the black box of that, and when they search for the black box, they look for the recording or what could have actually happened into that aeroplane that caused that crash, and then they prepare a report onto that what could be certain areas or how could this crash could have been prevented. But the similarity is that when the researchers or the team looks into the black box, they have no knowledge of how that incident happened. Similarly, if I'm discussing this black box testing into your programming concepts, That means that right now you are testing your algorithm or program, but you do not have that knowledge that what is happening inside that. You recognizes that. Whereas in terms of a white box testing, you have each and every module separately, and you test each and every module of that individually. Black box testing are difficult to design because many different inputs options have to be considered. And white box testing, the testers can identify the type of test data that is going to be required, and that could either be a valid, invalid, or extreme. Now, the point is that what is the need for having a test plan? Why do I need it? So the part problem is that I do prepare the software that is dependent on my analysis, that what I want the software to be and how I want the software to be, but it is important for me to test that for which purpose the software was created. Is it even following it or not? Testing is extremely important because your programmers or developers are not perfect. There could be errors that could be identified, and the ratio of the errors even increase when you have a more number of modules. So that you also need to synchronize all of the modules all together, and you need to check that if every part of my program is accurately working or not, individually and separately. These errors needs to be found and rectified, and it is quite important as well to ensure that systems are error free so that users can use the system as well. What is a test plan? A test plan is going to be a detailed and structured plan of how your testing should be carried out. A test plan basically identifies that all the tests that are needed for every input, every button, every link, every report, every screen, every element is working properly or not. A good test plan might be a systematic outline of that how all of your features and functionalities are quite working well as well. Like, for example, you can see right here that this is a number two, and discount formula for working hours of two, calculations charges per hour. ये कुछ एग्जांपल्स हैं यहाँ पे टेस्टिंग की. इसके बाद मेरे पास 16.4 है, और 16.4 मेरे पास इम्प्लीमेंटेशन पार्ट होता है. एंड जैसे कि यू कैन सी दैट दिस इज अ सिस्टमेटिक अप्रोच जो स्टार्ट हो रही है आपके एनालिसिस से. एनालिसिस के बाद डिज़ाइन पे गई, डिज़ाइन के बाद डेवलपमेंट एंड टेस्टिंग पे गई, और डेवलपमेंट और टेस्टिंग के बाद अभी आप लोगों के पास आ गई है इम्प्लीमेंटेशन स्टेज के ऊपर. दैट मीन्स कि अब आपका सॉफ्टवेयर एक्यूरेटली बन गया है, रेडी टू लॉन्च है. नाउ यू नीड टू इम्प्लीमेंट दैट. दिस आई कैन ऑल्सो यूज द टर्म इंस्टॉलेशन. मुझे उसको इंस्टॉल करना है. इम्प्लीमेंटेशन का मतलब है कि मेरा साइकिल जो है अब कंप्लीट हो गया है, अब मुझे इसको इम्प्लीमेंट करना है. अब देयर कैन बी फोर डिफरेंट मेथड्स ऑफ इम्प्लीमेंटिंग और इंस्टॉलिंग अ न्यू सिस्टम which can be remembered as the four P's. The first one is a parallel, phased, direct और pilot. अब as the word says, अगर मैं parallel running की बात कर रहा हूँ तो parallel running के अंदर देखो, most of the organizations or companies do not have a complete trust, or they have issues as well. Like, for example, if they just completely shift to the new software, their current working criteria, their current working database, or their current workflow is going to be disturbed. That what they do is that they say that when a new system and an old system runs at the same time, they introduce both of them at the same time, the new system will become live, but the old system will continue. And data is going to be duplicated from the older system to the newer system, and new data will need to be input into the both of the system. This keeps on going on until the organization have full confidence on the newer software and they are completely satisfied with the software. So just in case if there is any problem, they have the opportunity that they can revert back to that software. The second area of implementation is your direct changeover, and in direct changeover, you are given a date for the old system to stop running and the new system to start running. The systems do not run at the same time and there is a clear break. from the older system to the newer system. The data has to be transferred between your newer system and the older system. The third one is your phased implementation, and in phased implementation, you are breaking your implementation into some number of phases or into your some number of parts. This often takes place when there can be a large system with a lots of functionalities, and the old system will run until a date has been agreed, and at which point of the old system will be retired. So this is your phased implementation. You have pilot implementation as well, that takes place when a part of your organization starts to use the new system while the rest of the organization continues to use the old system. That means that half of it has been using the newer one, half of it is using the older one. The new system is effectively being tested by the group of users uh, who are able to deliver the trainings and the reasoning for their software as well. However, it can be quite important task to select that which of your option you need to select in your implementation task, right? Like for example, if I specifically talks about the parallel one, you know that this is less risky. Why is that? Because if the new system fails, the organization can continue to run the older system. That means that you have the opportunity. You are not completely trusting a newer system. The accuracy of the new system can be tested as well with this. However, you have certain disadvantages of that. Disadvantages as that like your data is going to be duplicated. There may be need for additional hardware as well. Data may need to be inputted, so there can be quite a lot of workload as well, and there can be a chaos and a problem as well, because now you are running the both of the systems at the same time. The second one is your direct, and in direct area, this is a cheap area to implement because there is no duplication of work. You just suddenly stop your older system and you start using the newer one. The data that is being used is going to be consistent, and there is no need for the new system to be compatible with the older one. This is quite a risky one because if the errors are found, or if there is a software failure, you do not have anything to rely on. However, all the trainings will needs to be done in your advance of changeover. So if there are a lot of users, this could result in some forgetting like what they have learned, so that there would be problems to start a new system. The third area is the phased one. That means that if there are certainly some areas where there are errors, you can revert back to the last phase, you can move on to the next phase, and your end user can be trained as far as keeps on introducing the new phases of your system. Disadvantages can be that delays are occurring as you are moving from one phase to another, second to third, third to fourth. Users will be using two different systems and they might be confused as to which part they are referring to the program. And similarly, your both systems that are in your older phase and the newer phase have to be compatible with each other. The last one is your pilot, and in your pilot area, if there are any errors, they will only affect the pilot group, like the one that is currently using the software. Any errors that are found by the pilot group can be fixed so that further users do not have to sacrifice. The pilot group can also train the other users as well, how to train them. Disadvantages can be, this can be actually a slower method because your half of the organization is on different software and half of the organization is on different software. This might also create a sense of sensitivity among the group of people as well. Like, for example, some people might say that we are some sort of special or we have this piece of software, whereas the other people might think that they do not have the opportunity to use that software first. They are might be not be there could be some level of difference. This could create a level of difference in your organization. And similarly, both of your older system and newer system have to be compatible with each other so that they can share. So I hope that it's clear with you and you don't have any queries. In your 16.5, this is your documentation area. And documentation area is quite an important one. And you have certainly different types of documentation as well. Like the first one is your technical documentations that provides you an overview of the structure of the system, that what are the technicalities, how it is put together, how it works. It also includes a data dictionary as well to show that how your code is being structured work. Like any programmer who wishes to automate the process, you can explain them with the help of your technical documentation, that what are certainly some validation routines that are being used in that, what are your programming techniques. Like For example, if you want to have a better technical overview, you can review this technical documentation. That is an overview, that is a structure of your system that is put in together to show that how it is actually working. You have user documentation as well, and there's a big difference between technical documentation and user documentation, because technical documentation is mostly based on the technical side of your system, whereas when it comes to a user documentation, it means that now you have your user in your mind. You are not going to tell the user the technicalities, because the user might not be program friendly. You just need to tell your user regarding that how you are going to identify the system, how you are going to use it, and what is going to be the purpose of that, what are your software requirements, your hardware requirements. And you can even show some photographs, your parts of your hardware. You can show some number of arrows to guide that how your software is working. You can also provide a glossary of numbers of alphabets as well to tell your user that how to operate the machine. It is basically a user guide giving the instructions on how to operate the system. Like, for example, certainly there is an example of a problem, that orange light being displayed on the printer. You have the cause and you have the solution as well. So with your user documentation, you are making your user friendly with your system. You can see that these are some examples of that. So you can definitely identify the error, you can provide the cause, and you can also provide the solution as well. Why technical and user documentation is needed? Now, this is an important area. A technical documentation, as discussed earlier, it is required by anybody that is carrying out the maintenance onto that system. And it is unlikely that the person carrying out future maintenance is the part of the original team. You can hire someone else as well. So it is quite important for that person to understand that how the things are actually working. And when it comes to a user documentation, you are telling your user that how to look into that system and how to work into that system. So there's a quite a difference between both of them. In 16.6, we have our evaluation part. And what is an evaluation? An evaluation can be like, for example, I gave you an exam, and now what I'm doing is that I'm evaluating it. I'm evaluating it, like what are the mistakes that you have done into your exam, what could have been done better, what you have not. So evaluation is when your system is being developed and it is completely installed, and now you are reviewing it. It is a formal review of a project. Users might be given questionnaires to find out what they think of the new system, what they feel like, what should be into that software, what should not be that software. An important question can be asked, like if the system is meeting the user's requirement or not, and if your each requirement is being considered in turn to determine if it fulfills or not, and even if it is not fulfilling, then what should be the appropriate way. You should be giving them feedback as well. Like, this is what I feel like. The requirement specifications have specified like how easy the system should be used. This can be like subjective, and this should be difficult to measure. But if you are having the feedback from your audience or from your user, you can adapt your software. Like, for example, you developed a software and now you are on the evaluation part, but some members of the team say that, sir, the software but which it was designated to create it is not working properly, or there are certain areas where there is a need for maintenance. So this is the area where the new cycle into your software start, that is to be known as maintenance. That means that now you also do not just need to create, develop, test, or review your project. You also have to maintain it timely. And you have two examples of your maintenance, or three, four, around four examples of your maintenance part. The first one is your perfective one, and as the name says, perfective. That means that the idea of perfective maintenance is to be always looking to improve the system. There may not be anything wrong with the system, but there can be ideas, there can be improvements to make your system work even better. So that means that your system is currently perfect, there are no faults into that, but as per the user wishes, as per the user wants new features to be added, new technology to be embedded into that. So this is what you use the perfective maintenance, you make it even more perfect. Like, if a system remains in place for a several years without any improvement, it might become outdated, inefficient, or obsolete as well. So it is highly important for the team to keep on updating it with the latest trends, with the latest technologies. The second one is an adaptive maintenance, and as the word says, adaptive, which means that now you are adapting to your environment. That system also needs to adapt to the change. There could be changes to your internal procedures within an organizations, or there could be some areas where the organization has no control. For example, governmental policies, governmental legislation, governmental process. There are areas where the company or the organization do not have any access to those. So then it is only on the team of the developers to amend that software, to adapt that software to the new changes that are recently brought. So this is the place where you use your adaptive maintenance. That means that now you are adapting to a newer technology, or you are adapting to a newer system that is introduced, and the cause of that can be governmental legislations or governmental policies as well. The third one is your preventive maintenance, and preventive maintenance, it is required to prevent problems that are arising within a system or into a system. This can mostly apply to both sides, like either hardware or either software as well. But hardware has to be regularly checked just to stop dust or anything from blocking any fans or storage media, or you need to check that if there is proper heat ventilation. You need to check that if there is not any sort of hardware failure. So data should be regularly checked. It should be regularly serviced with consistency and integrity so that you can prevent from any sort of damage. This is known as your preventive maintenance. The last one is your corrective maintenance, and in corrective maintenance, when any sort of errors or bugs are found, they have to be corrected. So this is the responsibility of the developer to correct them out. These can be corrected within the system, and so that it should be producing accurate results. So these maintenance are quite easy as well, and you do not need to just go through them line by line. They are quite understandable by what it is written. Like for example, if it is written perfective and maintenance, that means that right now my system is perfect, but now I'm improving it. I'm making it more perfect by adding and collaborating more ideas. If I'm giving you the example of adaptive maintenance, then adaptive maintenance means that now I'm adapting it to the new changes. If it is a preventive major maintenance, that means that I'm preventing it from the major faults and difficulties. If it's the corrective maintenance, that corrective maintenance means that now I am making it even more correct. How the maintenance should be carried out, there can be certainly different ways in which your maintenance should be carried out. One way is to be known as SDLC life cycle. That is to be known as a software development life cycle is produced, and the main stages of that software life cycle are, like for example, right here you can see as well that this is a diagram. This is identification and tracing, analysis, design, implementation, system testing, accepting testing, delivery, maintenance management. Maintenance needs to be go with this some different level of stages and software development. I can use this separate development and maintenance. That maintenance team will be different to the original team. You can hire anyone else. You can use a combined approach. You can combine both of the teams, and you can work on a single object. You can work on your functional approach that is similar to the combined approach, but systems personnel are assigned for the functional areas where an organization for both your development and maintenance. I have already discussed this page point in detail as well, so that you can just read it out. This page number 367. Let me just give you an overview of that as well. This is just about that how your maintenance start. Your maintenance start whenever you identify an error, and in your analysis stage, there is an impact analysis. Impact analysis identify that how your system is being working. You have your design stage. In your design stage, you have SDLC, that is software development life cycle. The implementation stage is similar to the development stage, but it should not be confused, like as it is not same. A software engineering can involve like deciding whether the whole system needs to be re-engineered or just a little part of that, performing reverse engineering, restructuring the programs, restructuring the data. The next area I have right here is 16.8, which is prototyping. And prototyping is basically a mock-up or a design of a software solution. Like, for example, you are asked to create a software, and even before developing that, you are asked to create a mock-up or a design of that. The first thing you do is that you just go on to your and you guys can even understand it better because you guys are the students of A-level IT and you have already given your P4. A prototype is one that you are creating a design of your software. You are just making sure that how your system is going to look like. It is used during your design stage to demonstrate that how it is working. It is used so that the client could get the feel, the client could get an idea that how the system is going to be, how it is going to work, what is going to be the look and feel of that. Because the user cannot the user cannot understand the programming, but the user can understand the look and feel. So if you provide them with a look and feel of that software, it would be appropriate for him to understand that how the things will work. The types of prototyping can be it can be an initial requirement, incremental prototyping. This types of prototyping takes an iterative approach. Iterative approach means repeating it again and again. In that, requirements are specified, initial prototype is developed, the prototype is reviewed, and then requirements are clarified. You can work on to initial requirements, initial prototype, feedback, and with the given feedback, you can refine your prototype, you can refine your requirements, and that's your final project. This is mostly referring to your design, but not design in terms of programming, design in terms of the user. That means that how it is going to be built, which product is going to be built, how it is going to be looked, how it is going to be functional, how it can be enhanced. Evolutionary prototyping means that you are basically following a pattern of something uh, that is not in an incremental prototyping. The difference between both of them is that in incremental prototyping, you are taking an repetitive approach. You are taking your requirements, you are shifting again from your requirements to your final objective. This is why it is an incremental approach, because incremental just means that you are incrementing it by the value of one. So it's up to you that even if you go forth and even if you go backward, but when it comes to an evolutionary prototyping, it means that now you are following a trend, you are following a pattern. That means that you might not have any requirement specified at the start of the project, but you know that what could be your goal, what is your aim. So analyst and the developer can brainstorm working on to that. So in evolutionary prototyping, you do not have an idea. You are collecting all of the ideas and you are bringing them all together. The analyst and developer is going to compare those nodes. The developer will demonstrate that how these ideas can be implemented, what could have been done, what could you do, what is the feedback, and how you could evolve them into a single product. The third one is your throwaway or rapid prototyping, and with throwaway or prototyping, as also known as rapid prototyping, the prototype will never become a part of the final delivered software. However, it is going to be discarded. It is like a working model that is being followed by a short investigation with an aim to get the feedback. But since if it is not accepted by the client or there are any sort of fault, so it is thrown away. Now, what can be the advantages and disadvantages of the prototyping? An advantage can be that problems could be identified, your problems could be identified, requirements have to be clarified, feedback can be taken from the clients as well. Your end user would know, like, for example, if you're giving a prototype of a software to a user, you are providing him with an ownership. It gives him the sensibility that I am asking my client that what should be the software or how you want it to be. So it gives a better impression to your clients as well. By listening to the feedback given by your client, you can even develop it even better. And there could be not a sense of that, like for example, your client asked for something else and you developed something else. So all of these problems can be prevented with the help of your prototype. When it comes to disadvantages, your requirement analysis can be rushed. Like the prototype does not might not reflect that what your user is expecting. It could be a disadvantages. Your prototyping might become too rushed when trying to develop into a system. So there can be design flaws or there could be structural flaws into that. And there could be another problem is that when mostly users look into that
prototyping, they might get too interesting or they might get too disappointed at the same time, or they might be having a more number of ideas that they want to collaborate, but it is a number of ideas for them, but for the programmer it's going to be a huge journey that they have to create the whole module and they have to associate it with them. So most of the users do not understand it, and they just throw away their unlimited number of ideas, so it creates a problems with the designer, with the programmers as well. The initial cost can be high compared to your design